All right, so we have previewed some problems of the highest level of difficulty, but guys, going from units of one substance to units of another substance is called stoichiometry, and that's what we're getting after today. We're trying to figure out how to use that mole map and how to convert from unit to unit effectively. So the first thing that we always need is a balanced chemical equation, okay? If we have a balanced chemical equation, then we're going to be able to use the mole ratio to go from substance to substance. For the sake of moving quickly in our notes, our equations will be balanced for us, but there are going to be times where you guys have to balance your own equation. If you do not use the balanced equation and you just use coefficients of 1 across the board, there's a good chance that your final answer is not going to be correct. So remember, our first step is identifying the given with units and the final unit that we're trying to go to. So let's go down to our question down here. It's asking how many grams of aluminum oxide would form if 12.5 moles of aluminum burned. So our given is that 12.5 moles of aluminum. Man, sorry, I kind of suck at this. This is my first time really making one of these. So if we have 12.5 moles of aluminum given to us, we're here in moles of substance A. Because remember, whatever substance A is what we're given. It's asking us for grams of aluminum oxide. So that's the new thing that we're going to, aluminum oxide, which would be substance B, and the grams of substance B, the mass box is over here. So now our job is to figure out what roads will lead us there. Our given's over 1, and the next ratio that we're going to need to use is this moles B over moles A, where moles B is what we're wanting to get to, aluminum oxide. The coefficient in front of the aluminum oxide is 2. So that's going to be 2 moles of Al2O3 on top over 4 moles of aluminum. And moles of aluminum cancel out. But we're not looking for moles of aluminum oxide. We're looking for grams of aluminum oxide. So now we need to follow the next path where x grams is equal to 1 mole. Guys, x does not equal 1. We need to actually calculate the molar mass for aluminum oxide. So for every 1 aluminum oxide, we have 2 aluminums, and the mass on the periodic table for aluminum is 26.98. When we multiply that by 2, we get 53.96, and we have 3 oxygens. So we've got 3 times 16.00, which is going to be 48.00. Collectively, that's 101.96 grams of aluminum oxide. So moles of aluminum oxide cancel out. We're left with grams of aluminum oxide on top, which is awesome. That means we're ready to solve. Our given has 3 significant figures, so we're rounding our final answer to 3 significant figures. When you do it in your calculator, it's 637.25, where 7 is the 3rd significant digit. To the right of the 7 is a 2, causing the 7 to stay the same. Not only do we need our unit grams, but we need our substance Al2O3. So we're going to do one more problem, one on the top of page 18, and this one says how many particles of oxygen are needed to react with 100.0 grams of aluminum. So our given is grams of aluminum. So we're starting with 100.0 grams of aluminum over 1, and we're in the mass box. And guys, the only way out of the mass box is to follow the road with 1 mole over x grams. So this is still substance A. We have moles of aluminum over grams of aluminum, and if you look at your periodic table, the molar mass for aluminum is 26.98 grams. Grams of aluminum cancel out. We're left with moles of aluminum, but we're trying to change substances, right? We're trying to get to particles of oxygen, which means we're going to have to cross the mole bridge using the balanced chemical equation. Now, that was on the other side. So we have 4Al plus 3O2 yielding 2Al2O3s. The coefficient in front of aluminum is 4, so we've got 4 moles of aluminum on the bottom so that moles of aluminum can cancel out. And we're trying to get to particles of oxygen. In front of oxygen, we see that 3, so we have 3 moles of O2 on top. We're not trying to get to moles of oxygen, we're trying to get to particles of oxygen. And the only way to get to particles of our desired substance, substance B, is to follow the arrow that goes down, and with that is 6.022 times 10 to the 23rd particles of O2 over 1 mole of O2. Moles of O2 cancel out, which means we're ready to solve because we've got our desired substance, particles of O2, on top of the last ratio. When we solve, because our given has 4 significant figures, our final answer should have 4 significant figures, and you should be coming up with 1.674 times 10 to the 24th particles of O2. I hope this gets you started. Shouldn't be too difficult, guys. And I know you're up for the challenge. We're going to be working on stoichiometry worksheet 1 today in class. It's due tomorrow when you come in, and we'll probably just work on stoic worksheet 2 and 3 tomorrow in class. Quiz on Wednesday.